Good morning, afternoon, or night, whenever you're watching this. We are in Geometry B, Law of Science. Congratulations that you made it this far. You are now officially at the hardest point in this class. And if that sounds terrible to you, then don't worry. After this week, the class will get much easier. If you're like, really? Is this it? Then perfect. You're going to have no problem. Either way, you're almost done, good or bad. So keep it up. And let's dive into this. Law of Science allows you to find the unknown measures for a triangle as long as you know either of the following conditions. Condition one, if you know two measure angles and any one side length, ASA, or if you have condition two, if you know two of the side lengths and one angle, SAS. You also need to know the definition for triangle sum theorem. We've gone over this already, but I just felt like I needed to include it here. All three angles in a triangle must add up to equal exactly 180 degrees. And you're going to use this in every single problem, at least once. Okay. But back to the thing that you've been everything's been leading up to. Now, normally at this point in the geometry class, there is something beyond this that is in the curriculum. Unfortunately, due to the way that we're only doing this in 5 weeks, I had to cut some things out. So this is about as far as we're gonna go into the trigonometry stuff. So that's why I said this is the hardest part of the class, and then the other things will be easier. Um, but you do have to prove that you know what law of sines is, because what you guys have been doing with the tangents, sine, and cosine is whenever there's a right triangle, right? Whenever there is, let's see, whenever there was a triangle that looked like this and had specifically, no, that's terrible. Okay, let's just do this. Let's do that. There. Okay, so whenever in the last 2 weeks, you've been dealing with this kind of triangle, right? You've been dealing with the kind of triangle that has a 90-degree angle, at least one of them, and all the sides are proportional to each other. Well, although this is very important, in the real world, not everything is a perfect right triangle, right? There's only a few instances in which you'll catch them, and if you are doing construction, yes, you will be using right triangles a lot, but that's on purpose. Nature tends to have shapes of all sizes. And when you come across a triangle in particular that's not 90 degrees, right? That is an irregular triangle that not all the sides match, you're still going to need to find a way to figure out missing side lengths or missing angles using geometry. And the tool that you're going to be using is called the law of sines, right? So at this point, you're probably asking, well, what is it? Well, this formula is a little different from everything you've seen so far because it's not really a formula. I mean, it is, I guess you can call it that. They're ratios. Ratios, remember, are just fractions. And they do have to do with one another. All right. But you're not going to use all three in a single part at the same time. Meaning you're never going to need all three of these at once. You're going to need two of them at once, and you're going to compare one to the other, and you're going to solve for the missing side. If this doesn't make any sense, that's okay. We're going to go over everything. For now, I'd like to direct your attention to this triangle right here. This is the kind of triangle that we're going to be working with. Now, if you notice, there's capital letters and then there's lowercase letters, right? Yeah, that's an E. Okay. So capital letters. Capital letters in particular, and you're gonna see this throughout all the problems that you're gonna do this week. Every time we have a capital letter, it's always gonna be at the corner of one of the triangles. And that's because it's representing measure angles. Measure angles in degrees. Measure angles in degrees. And the lowercase letters, right? These ones, the lowercase c, the lowercase a, the little b, those are all going to represent Those are all going to represent the side lengths of the triangle. And this is important because I want you to take this information and I want you to apply it to the formula that we have up here. Now, the formula for the law of sines goes as follows. Sine of parentheses A, or measure angle A, right, close parentheses, is being divided by the lowercase a. And this is important because that first one is representing this. I want you to think of these like a set, you know, like one relates to the other, and it has to be proportional to the other one, okay? And because if you increase what A is, like the capital A, like if the degree gets larger, then the side length of the triangle, little a, will also have to get larger to compensate for the change, meaning they're related. A, capital A and lowercase a are not representing the same thing, but they are related. One will change what changed in one will change the other one. That's why I put a circle around them, because that's a set and they belong in the same ratio. Notice how it says sin of A, right, over little a is equal to sine of B, capital B, being divided by lowercase b. That would be this right here, right? What it's saying is the proportion of big B to little b is the same as the proportion of big A to little a, right? Additionally, as you can see the next part, all of those are also equal to this one. So if you notice, it makes a kind of a weird shape, right? Well, I want you to look at these circles the way I did them, because the circles are going to be a key way for you to visually keep track of what you're supposed to be doing. I know this looks confusing, and I know it probably sounds ridiculous, but just the circles are going to be your friend. Just trust the circles, right? Why don't we get into what this actually looks like, right? Because now you know what we use the law of sines for. We use them to find missing sides for triangles that are not 90 degrees, right? And let's go back to these conditions now that we kind of know a little bit about what it is. Notice what it says. Law of sines allows you to find the unknown measures of a triangle so long as you know either of the following. That means if you have at least two of the angles in that triangle and at least one of the side lengths, you can figure out the other ones. You can figure out the other three pieces of information just using that information. Or if you know two of the side lengths and one of the angles, then that's also enough information for you to use the law of sines to figure out the remaining pieces of unknown information on the triangle. All right. Let's move on to a problem, right? Because no matter how much I explain, it's best to just look at a problem. So right here, using the law of sines to find the missing side lengths. Now, I want to point something out to you. You guys see this where it says part 1? This problem, in order to solve for this problem has 3 answers that you need to find. So naturally, that means that there's going to be 3 parts to this problem. This slide is only part 1, right? But in order for us to determine what we should do first, whenever we're doing one of these problems, we always want to look at the triangle, right? The triangle is right here. And we want to ascertain what pieces of information are missing and what should I find, right? Now, if you notice the problem, right? Let's take a look at what the problem says. Problem, find all unknown measures, that's supposed to say using, the given triangle. Okay, so, well, a couple things here. I don't know what lowercase s is. I do know what capital S is because right here it has this, right? It has 38. R has 35. I don't know what T is, and I don't know what lowercase t is. But I actually do know what R is. I know it doesn't show me, but I should know that opposites, right? Opposite to the capital R should be little r. The side length that is opposite to that R should be little r. So I know that the 15 is actually little r, okay? Just like I know that opposite to capital S is a lowercase s. Just like I know that opposite to capital T is a lowercase t. So here, my objective as I begin this problem, objective, right, is to find, let's see, measure angle T is to find side S and to find side T. Now, right off the bat, there's something I can figure out right away, right? Remember that triangle sum theory that I talked about in the beginning? Remember I said all three angles inside of this of a triangle have to add up to equal 180? Well, just subtract them from 180 and you're going to get your missing angle. Why? Because if you know that R is 35 and you know that S is 38, you can add them together, subtract them from 180, and whatever's left over has to be T. That's exactly what I did here. Measure angle R plus measure angle S plus measure angle T equals 180 degrees. This is the triangle sum theory. I'm just going to call it TST for now. Then what I did was I substituted what I know, right? I'm going to just write sub here. I know that measure angle R is 35, which explains the 35. It explains the 38. I took them directly from my picture, right? My triangle. And then I just left plus measure angle T because that's what I want to know, right? Equals 180 degrees. Okay, cool. Add 38 and 35. This is combining like terms. It's a little bit of algebra, but it's okay. So combine like terms, right? So 35 plus 38 gives me 73. That's right here, should be a 73, in case you can't see that. Plus measure angle T is equal to 180. All right. So now I have to combine like terms. I also have to do what we call inverse operations. Now, if you've been paying attention the last couple of weeks, inverse operations is just the opposite operation to what is currently happening in order for you to isolate the x. In this case, we don't have an x, but we do have an unknown. We don't know what measure angle T is. Therefore, that is my x. That is what I'm looking for. I subtract 73 from both sides, right? Because I want measure angle T to be alone on the left side of the equation. So I cancel out 73 from both sides. That means subtracting 73 from both sides. And I end up with measure angle T is equal to 107 degrees. Perfect. Do I now know what measure angle T is? Yes. I know that that is 107 degrees. Am I done? No. No, because I still don't know what measure angle S is, and I still don't know what measure angle T is. But now that I know what this is, right, I can figure out the other two things, right? One thing I want to point out before we move on to the next thing. I'm going to go ahead. Remember I said circles are going to be your friend? I'm going to go ahead and circle this whole thing. This R is special. And it's something I should be paying attention to. Why? Because measure angle R, I know what measure angle R is. It's 35. And without doing any math, because this was given to me, right? This was already part of the problem. I happen to know that little r is 15. That is what we call your complete ratio. That is that is my completed sets, or whatever you want to call it. That the R set is complete. That way, when I compare that ratio to another ratio that is missing a side, I know that my R is the important one. And what I mean by that is what I'm going to do next. All right, part two. All right, so I figured out that T is 107. I've already included it here. If you notice, it's in here. I'm including my information, right? Okay, so how do I find S and lowercase s and lowercase t? Well, funny thing, remember how we circled this? This is what we call our completed set, right? And we're gonna compare, or we're gonna compare we're gonna make a proportion. We're gonna compare big R and little r to either big S, capital S and lowercase s, or capital T and lowercase t. Now, depending on which one I want to solve first. Technically, right now, I have enough information so that I can pick either or. It honestly doesn't matter. So what I'm going to do is I'm just going to pick T. Why? Because I just figured out what T was. I mean, there's literally no other reason. I could figure out what S is right now, and I'm going to do that in the next slide. But I'm going to just focus on these two. These two are now officially my two fractions that I'm going to compare. Now, if you notice, I have law of sines ratio as my step 1. But if you notice, I don't have all my ratios, right? I only have 2. If we go back to the original equation for law of sines, if you notice something, I have all 3 equaling each other. Well, right now, you're not going to use all 3. You're never going to use all 3. I want you to use them in like one comparing to the other, right? So we have our, what we call our completed set. Our completed set is this one. This is the important one. Sine of r over little r is going to be equal to the one I'm trying to find. Now, I know what capital T is right now, but I don't know what lowercase t is, so I'm going to pick that one. Sine of capital T divided by lowercase t. That's my law of sines ratio. I don't need to include S right now. S doesn't exist right now. I'm going to deal with S in the next slide, okay? Right now, I'm going to substitute the information. Okay, so now that I know that I have my ratios correct, right, and they're equaling each other, let's go ahead and replace the variables. The sine of t is just, as we've said in the last problem, in the last slide, it's 107. So I'm going to replace 107 for t, sine of 107 divided by, and then I don't know what lowercase t is. I'm looking for lowercase t, so I'm going to just write lowercase t. You're confused? I'm right here. Next, that's going to equal to sine of 35, because sine of r, remember r was 35, right? It's up here. So sine of 35 divided by 15, because little r is 15. Okay. Now, if you notice, there's these little arrows I got going on. If you're wondering what that is, that's what we call cross multiplying. This should sound familiar. If it doesn't, that's okay. Basically, I want to draw your attention here for a second because I'm going to do a quick problem. Let's do something like 35x is equal to 2 over 4. If I were to solve this problem and I wanted to find out what x is, I would do something called cross multiplying. And what that means is I multiply the 35 by the 4, and I multiply the x by the 2, and I keep the equal sign in the middle. That means 35 times 4 equals 2x. And this is going to be 140 is equal to 2x divided by 2 divided by 2. X is now equal to 70. And if I were to put it inside the x, 35 divided by 70 is 1/2. And 1/2 is the same as 2 over 4. In other words, if you have two fractions and they happen to equal each other, and you're missing one of the pieces of information, you can figure out what it is by using a proportion, okay? Go ahead and pause the video if you want to write that little example down. I'm going to erase it because I need the room, all right? Oh, no, I did something terrible. All right, go back, go back. All right, there it is. It's back. Okay. Yeah, that's good enough. Okay, so we're going to do the same concept, but with bigger numbers, right? So now that everything is there, I'm going to cross multiply. In other words, this top part, right, sine of 107 is going to multiply by 15. And notice those two came down here, right? They're right there. Then we're going to put equals, and then t, right? I'm going to put a square on this, t, and sine of that are going to multiply together as well. If you notice, they're on this side of the equation now. That's what it means to cross multiply. The equal sign is still in between them, and one of them is going to end up on one side of the equation, and the other one's going to end up on the other side. Then I kind of combine the step inverse operations to isolate the variable. What that means is I don't know what t is, which means I can't multiply it by sine 35, but I can get rid of it. Now, since sine 35 is multiplying by t, I had to do the opposite, meaning I had to divide both sides by sine 35, which is why I wrote sine 35 underneath, which is why I did that. Because now I can cancel it out. I don't care what sine 35 is because I just cancel it out. It doesn't exist anymore, at least not on this side. But what I do to one side of the equation, I have to do it to the other side, which is why the sin 107 times 15 is now being divided by sin 35. All right, now here comes the tricky part, okay? because you might be, if you're following along, you're like, okay, I think I kind of get where you're coming. I guess I can kind of see where you're getting your information from. If you're right there at that point where you're still kind of like, I don't know, you're in a good position. Okay, no one understands this the first time. All right, I didn't understand this the first time I learned it, but after a couple times, it made sense. So here, I want to direct your attention down here, right? Because there's a lot of stuff going on down there. I'm giving you two options on how to calculate this, okay? Because I know some of you are using your iPhones, and if you've been paying attention in the last couple of videos, I don't like iPhones. I don't like, specifically, I don't like the iPhone calculator because I haven't figured out a way for it to show you what you've done. And it just calculates things for you without showing you what you did. So you can't even check if you're right or wrong. Um, so, like I said, you have two options to do this. If you're using an iPhone calculator, try doing it this way. You can still use it, but you're just going to have to write down everything and you're going to calculate everything manually. What that means is on your iPhone calculator, instead of writing sin of 107 times 15 divided by sin 35, what you have to do is do sin 107 equals, and it'll give you 0.954 something, something, something. Notice I wrote that down here, 0.95, right? Times 15, I don't have to do anything with it. I just leave it as times. And divided by 0.57. Multiply 0.95 times 15 in your calculator. And you're gonna get like 14 point something, right? That should be the number that pops up on your iPhone, right? And once you have the 14 point something, excuse me, then you're gonna put the division symbol, right? Divided, and then you're gonna put 0.57. And then you're gonna press equals, and you should get your answer. Right? You have to do it in that order. You have to convert sign of whatever degree into a decimal, then multiply a decimal by whatever it was multiplying, and then whatever that answer is, at the end, do the division. You basically do have to put in everything for the calculator to solve individually. The calculator cannot automate it for you. If you did everything right, you should get t is equal to 25 on your iPhone. If you're like, Mister, I don't have an iPhone, or Mister, I don't have a phone at all, right? You can use the Desmos calculator that is, the link is above, right, in the Google Classroom, or you can just do this extra step. You can simplify for the calculator. And if you have an Android, it's significantly easier. Type it in exactly the way you have it, you see it right here. Sign, parentheses, 107, close parentheses, open parentheses, 15, close parentheses. Look for the division symbol. And then open a parentheses again. Then put sign, and a sign and a parentheses should pop up. And you put 35, close parentheses. And you should get 25. And the calculator does all that for you. So you have two options. You're still doing a lot of work. And depending on which option you decide to do, I still want to see everything. Meaning, if you decide to go the calculator route, I still want to see these steps right here. I still want to see all of those. And once you have it in a fraction like that, I want to see you write it out exactly the way you put it into the calculator, and then you can put your answer. If you're like, I don't want to do it that way, I still want to see the first three steps. And then I want to see your final, the final numbers. I want to see the fraction the way I have it here. And then you can put 25, right? Bottom line is, this stuff is hard. And you're going to make mistakes because there's a lot of stuff to keep track of. And even if you keep track of everything, there's always human error when you're putting things into the calculator. And if you run into things like syntax error, that means that you forgot to put a division sign or a parenthesis somewhere. If it says, that's if it says syntax error. If it says like math error, you accidentally divided by 0 or something. So you did something to confuse the computer. Yeah, so if you get an answer that just does not look right, and you cannot for the life of yourself figure out what it is, this is where all the steps come in. Write down all your steps, leave a little note in your work to say, I'm not sure how I got this, right? Then I can see where you went wrong. Because what I'm really doing when I'm grading this stuff is I'm going to be looking to see if you can follow the steps, right? I'm going to be looking to see if you can show your work, if you can essentially justify what you just did. Because there are calculators that could essentially give you the answer. It can scan it and it can give you an answer. But the thing about those calculators is they won't explain to you how it did it. And even if it does, it uses notations that I am not showing you on this video. And that's done on purpose because if you try to use those notations and you can't explain those notations, well, guess what? I know that you didn't actually do it and I'm not going to give you points. So for most of you, you won't have this issue because I know a lot of you actually show your work. So I'm not worried. But for those of you who are like, I'm feeling so frustrated, I just want to put an answer and get this over with. All I'm asking is that you try your best. I'm not going to take points off if you're off by a little bit. If I can see where you went wrong, you're going to get the points. I just want to see that you tried. Right? Okay, good. Let's move on because we still have to figure out what the last side length is. All right, so we figured out that the side length was 25. You see this? I updated it, right? We still have an entire side to figure out. We still have to figure out what, oh, I'm sorry. Whoa, I think I did something wrong here. Okay, I figured out what T was, right? That was what the last one says. Yeah, T was 25. Okay, this is what I mean by mistakes. It happens to everyone. We still don't know what that is, but we did figure out that T was 25 from the last part. Now we're in part 3 because we need to figure out the last part, which is S. Again, the exact same thing. We're going to do the exact same thing, but this time, instead of having the ratio, we're still going to use this as the ratio that's completed, even though the T is technically completed. I could use T if I wanted to. I'm not going to. I'm going to use R and S, and I'm going to compare those two. Sine of R over little r is equal to sine of S over little s. Then I'm going to substitute. I'm going to cross multiply, right? Sin of R is sin of 35 divided by 15 is equal to sine of S, which is now we know is 38, divided by lowercase s, which we don't know what it is. Okay. So sine of 35, right, is going to multiply. Remember this? Cross multiplies by the s, which is why this is my number right there. Then 15 is going to multiply by the other fractions numerator, sin 35, which is where this comes from. Sin 38 times 15, right? And now I have to do inverse operations. I have to get rid of, if you notice, sin 35 this time, right? I want to point out something. Last time, sin 35 was on the right side of the equation. This time, sin 35 is on the left side of the equation. It ultimately just depends on which one you decided to put first. It's up to you to recognize where the variable is, right? You need to always look to where the variable is. And then whatever's attached to the variable, that's what you're going to divide everything by. So if you notice, sin 35 is what I'm dividing everything by, sin 35. Then I'm giving you the two options, right? You can either spell out what sin 38 is on the calculator, which happens to be 0.62, by the way, times 15 divided by whatever sin 35 is, which happens to be 0.57, right? This, and then you multiply 0.62 times 15, and you're gonna get like, again, you're gonna get like 14 something, or 13 something. I don't, wait, no, 15 is, sorry, you're gonna get like 8 something. Sorry, I did that math wrong in my head. You're gonna get like 8 something divided by 0.57, and then you end up getting S is 16. Or you can translate for the calculator, right? You can just take your sine 35 divided by sine 38 times 15 divided by sine 35, put it into scientific calculator notation, and it should pop up with 16. Again, if it doesn't give you 16, try putting this into your calculator unless you have an iPhone, in which you can't. But if you have an Android or you have the decimals, try putting it exactly the way you see it right here. Copy it down in your notes. If it doesn't work, try it without the parentheses around the second sin, around sin 35, right? So if this doesn't work, which it works on my calculator, but you know, every calculator is different. You can always try it by not. You can always just double check to make sure it's right. Usually you forgot something, you forgot a parenthesis somewhere. There'll be a mistake. Okay. And then now we know that this is 16. My information is complete. I am done with the problem. Cool. Don't hate me, but there is another problem. Okay, so we're almost done. Let's power through this because yes, I am tired too. If you're watching this with all like, you're kind of watching this all at once, I suggest you take a break, look through your notes, try out the first couple problems on one of the worksheets, and then when you get to the point where you look at a problem that looks like this, come back, let your brain rest. If you're like, nah, I got it, all right, then just keep taking notes. All right, so what happens if there's only one angle and two side lengths, SSA, or AS, or SAS as well? Well, it changes the order in which you're going to solve things. You're still going to have to do 3 parts, and each part is going to have its own steps, but you have to think logically about this, right? First thing I have to identify, do I have a completed side? Do I have a completed set? Yes, it's capital B. I know that. That's 33. I know that lowercase b is 12. That is my completed set. Right? But I don't have the other 2 angles, which means I can't figure out what angle A or angle C is unless I use the law of sines. Right? But this time, notice last time we were trying to find a side length. This time we're going to have to find an angle, which means we're going to have an extra step at the very end. Okay? So we're going to start with our completed angle, our completed set. Sine of capital B divided by lowercase b is equal to sine of capital C divided by lowercase c. This is, once again, just the law of sines. So at this point, you're going to have to just substitute, right? When you're going to have to substitute sine of 35, right? Because B, did I put 35? Whoops. Was this supposed to be 35? Okay. Well, we're going to go with 35 because that's what the calculations say right there. Sine of 35 divided by 12 is equal to sine of C divided by 15. Now, notice that's not a normal situation. I cannot stress this enough. You are going to have to make some changes at the very end. So this is sine 35 multiplying by cross multiply, right? So we have sine of 35 right here. At the very top, it's going to multiply by the 15, which is where we get this from. It's going to equal 12 times sine of C. So I have sine of C times 12, okay? Now, if you notice here, right, we're going to have to isolate sine of C. But I want to stress something here. Sine of C is not like your regular, it's an angle. You're looking for an angle. And when you're looking for an angle, you're going to have to use inverse sine. Right? I should just come out and say it because there's no other way of explaining it here. Yes, you are still going to have to, you are going to treat sine of C like it's a variable, but it's not a regular variable. You're going to still have to isolate, right? So you're going to have to use inverse operations to isolate. So divide both sides by 12, cancel it out, and you're left with sine of C is equal to whatever sine of 35 is, which apparently I have is 0.54 times 15 divided by 12, right? So, sorry, it's driving me crazy that I think I might have put the wrong angle. Let me just double check my notes here really fast. Because, yep, I messed up. So give me 1 second to fix this. Yeah, this was 33 the entire time. It's the other ones that were wrong. Let's see. Yeah, sorry about that. Okay, so sine of 33. Okay, so at this point you have sine of C is equal to, and we have a fraction. We have 0.54 times 15 divided by 12. Yes, I can solve for that, but if I do things the way I normally did in the like in the last problem, I'm gonna end up with something like 7.5 or something or whatever it is divided by 12. That's gonna give me a decimal. That is gonna give me a decimal of 0.675. That is not my angle. My angle is not 0.675. Like that whole thing, right? That whole fraction, if you were to do it on your calculator, ends up being 0.675. That doesn't make any sense. And that's because, again, this gives you the inverse of what you want. So you need to fix it by doing the inverse sign. Sine of -1. You guys remember this? Sine of -1, parentheses, 6.705 is going to give you your angle, which happens to be a number that makes a lot more sense, 42. Okay, so now you're going to have to do it. Now, if you're thinking like, okay, but how am I going to know when to use the sine -1 and when not to use it? Well, again, you're going to have to, this is where you have to look at what they're asking you. If they're asking you to find an angle and you are forced to use the sine because remember, if you already know what two of the angles are, you can just use the triangle sum theorem, right? You can just add them up and subtract them from 180. But if you only have one angle, you can't do that. You're going to have to find out what one of the angles are, and you're going to have to do this, essentially, right? Okay. Now that we know what that is, we can find out the other two parts. This is just part one. And yes, this is all just one problem. Well, this is a second problem. There's two problems, right? Each problem has 3 parts. So we're gonna find measure angle A. Now that we know, if you notice here, I did that. I included it into my triangle now. So find measure angle A using the triangle sum theorem. Hey, now that I have 2 angles, I can 100% use the easy theorem to figure out what A is, right? Measure angle A plus measure angle B plus measure angle C equals 180. I just plug in 33 and 42, and it should give me 75. Subtract 75 from both sides, and I have measure angle A equals 105. All right, not bad. Okay, I'm done with part 2. Now, it looks like the last thing I need to do is find out what lowercase a is. And I'm going to need to use that law of sines. So sine of measure angle B, right? Because that's my completed one. I'm going to go ahead and do a circle around it. My completed one, I'm going to start with that fraction, is equal to the one I'm trying to find. Now remember, I'm trying to find this because I already know what the other one is. So I have to do sin of A. Sin of capital B divided by lowercase b equals sin of A, sine of A, divided by lowercase a. All right, that is my law of sines. Now my law of my substitute. I'm going to substitute what I know. Since I know that sine of B, right? That measure angle, sine of measure angle B is 33. 33 in parentheses divided by 12, because lowercase b is 12, equals sine of capital A, which we found out in the last step, right? In the last part, that is, it's 105. So 105 divided by lowercase a, we don't know what lowercase a is. Perfect. Let's go ahead and cross multiply, right? That sine of 33 times the a goes here, and 12 times sine of 105 goes here, right? Now, over here, after I cross multiplied, I'm going to have to do inverse operations, because I got to make sure that a is by itself. And currently, a is multiplying by sine of 33, so I have to do the opposite of multiplication. I have to divide both sides by sine 33, so I can cancel it out here, and a will be by itself. Then I end up with sine of 33 on the other side. All right. So now, if again you're using it, if you're using a regular calculator, or if you're using a iPhone scientific calculator, go ahead and make sure you put sine of 105. You should get 0.97. You write it down like this, becomes this, right? Times 12 divided by 0.57, right? And you should get something like 10 point something, or 11, low 11s. I don't know which one. I think it's like low 11s. Divided by 0.57, which should give you 21 point something, which you're going to just round to the nearest whole number, which is just 21. Or if you're using the Desmos calculator, right, you're going to want to put sine of 105 in parentheses, close them, open them again, put 15, close them, divided by sine of 33. Make sure there is parentheses around this, double parentheses, because otherwise what will happen is if you don't put parentheses, you're going to get something different. Like the calculator will think that it has to do the sign. It'll multiply first, and then it might not divide, depending on the type of calculator that you're using. Again, this is all just kind of like we just have to get used to using the calculator for the most part. Okay. Now, with that said, we found out what it was. It is 21. So that's it. That's how we can figure it out. I know this was a lot. And once again, I'm grading you based off of, can you show me the steps? Can you tell me what the steps are? Did you put everything in the right place? Kind of deal. If you get something wrong due to a minor error, but I can see all your work, then you'll get credit, even if you got it wrong. I want to see all the work, right? Because the whole point is, can you understand where everything goes and what the steps are, and how can you do that? Given the limited amount of time, that's about as far into it as we can get into it. And just so you guys know, I mean, we did sines last week and cosines, and this week we're doing law of sines. So you might be wondering, is there a law of cosines? And the answer is yes, of course there is. And I guarantee you it is way harder than this law of sine stuff is. However, we're not going to do it. Nope. If you were in my regular class, we would do that. We would definitely get into the law of cosines. But we are limited by time, and there are other things that you should know how to do, in particular when it comes to volume and surface area, which is the next 2 weeks. Okay, so good luck, and please email me for Zoom appointments, because if you go into the comment section, um, especially the class comments, and you're like, I need help in the class comments, I don't get notifications for class comments. So like I have to constantly check, and that means that I won't see your comment for days sometimes. especially if you commented on the weekend, I might not see it because I'm doing other stuff. However, if during the week you send me an email and you ask to for a one-on-one Zoom session, right? We can make that happen. All right. So just you guys know my email already. Good luck.